Hello all, we got a pretty quick problem, so let's get to it. The statement reads, a dielectric cube of side A, centered at the origin, carries a frozen-in polarization P equal Kr, where K is a constant. Find all the bound charges and check that they add up to 0. So for our solution, let's start with the volume bound charge. Recall that rho B is equal to the negative divergence of P. And then we just plug in the definition. Since P is equal to Kr, where R is just a coordinate vector. In the angle brackets, we have x, y, z. Dot them, and then we simplify down to negative 3K. Pretty simple. So then the total bound charge is Q total is equal to rho, the density, times the volume, which is just equal to a cubed since we're a cube. And then we see that our final answer is negative 3K a cubed. Pretty simple. Now for the surface bound charge, we have to take into account which surface we're talking about. So for the top surface, for example, sigma B is equal to P dot n hat, which is equal to K. For the top face is equal to K angle bracket 0, 0, A over 2, since at the top face, X and Y are 0, and we're splitting the height in half, so A is divided by 2 in the Z direction. And then we dot that with the Z hat direction of N, and we're left with K times A over 2, which happens to be the case for all the surfaces. If you go through it all, the negatives will cancel respectively. So the total surface bound charge is Q surface is equal to A, the total area of the cube, times the surface bound charge, where we see we have 6 faces, and each of their faces has a squared area, and we multiply that by K, A over 2. We see that the 6 and the 2 cancel to 3, so we're left with a positive 3K A squared. And then if we add that together with the volume bound charge, we see that they cancel one another. Therefore, the total bound charge is 0.